Right. Gaurav,
Yes, sir.
I will send you the recording of one lecture, but last lecture na I could not record. Just go through those. Some doubt comes, ask me. I will send the solution.
Yeah, okay, sir.
That Aryan's book which means like we which I brought from that I have to start something or like what should I have to do?
Whenever you get time, you can start. Right now, you will not get time. So many homework stuff here.
Yes, sir.
This week don't start, but whenever you get time, you can start. Just wait. I will tell when to start.
Okay.
Done, sir.
After knowing what is H, I can think of H by E or H second one or third one which is having dimension of resistance. Having dimension of resistance means unit should come like ohms, na?
Yes.
Okay. H unit is joule second, just now we saw. Charge is coulomb, correct?
Yes.
So joule I can write work, coulomb is Q into second, work is potential is defined as work upon charge. So voltage into second, it can't be ohms because in ohms we don't get second. See, R is V upon I. तो अगर एम्पियर आता अपॉन तो आई कुड हैव टोल्ड इट इज सिमिलर टू रेजिस्टेंस. So this is not similar to resistance. Have you followed?
Yes, sir.
H square upon E. H square upon E means one more joule second will come. That means whatever I got into joule second more will come. Correct? No? Voltage second into joule second more will come. Got it? Hello?
Yes, sir.
Yes, sir.
अब इसमें देखो second is not getting eliminated. H upon E square is joule second upon charge Q square. E is same as charge. So joule means work. Work upon charge into second upon charge. Work upon charge is voltage into second. Charge Q is I into T. Second and time cancel. V upon I is similar to resistance or not? Tell me.
Yes, sir.
Yes, sir.
Answer will be H upon E square. So that means only difficulty is remembering all the quantities and also understanding which you have not done. So this dimension section is slightly difficult because few quantities you are studying before the studies of entire chapter.
done, sir.
Everybody is done?
Yes, sir.
Yes, sir.
Great. Come to 10. Consider expression f equal to ax sine inverse t. F is force, x is displacement, distance, t is time. Then what is dimensionally AB quantity equivalent to? AB is equivalent to what they want? Which quantity? See, whenever it is given in sine or E, then this part is actually angle. This is dimensionless. When I write sine 30 equal to half, so we say 30 is sine inverse half is the method. That means if sine theta is something as A, then angle theta is sine inverse A. Theta means radian. Radian is dimensionless. So always with sine inverse, if something is there, it should be dimensionless because it is angle. So BT is dimensionless. From this I get idea B is dimension of 1 upon 2. So this part over for me. Now this 2 must be matching because this is so dimensionless. So force ka dimension will be matched with this product. So I can say AX is similar to dimension of F. A is similar to F upon X dimension. You all followed this one? This much you all have followed?
Yes, sir.
Yes, sir.
But we are interested in A and B together dimension will be of which quantity, or together they will represent which quantity. A into B will be F upon X into 1 upon time. Force upon displacement is pressure, but extra time is there, so it can't be pressure. Force upon length is surface tension, extra time, it can't be there. So what I am doing, I am multiplying by X and dividing by X. This I did from my side. Force into displacement is work and similar to energy also, correct? So can I say numerator it's like energy, force into displacement? Hello?
Yes, sir.
And X into X is like area
Yes, sir.
into time. Energy per unit time per unit area is called as intensity. Energy per unit time per unit area is called as intensity. Any option is there? Intensity?
Yes,
Yes, sir.
sir.
Intensity of light.
Option C. Correct. Right. Intensity of light.
Done, sir.
Done, sir.
Let dimension of heat capacity. So first I should know what is heat capacity. Are you remembering in 10th you did the amount of heat required to raise the temperature of unit mass of substance, amount of heat required to raise the temperature of unit mass of substance by 1 degree Celsius or 1 Kelvin is called as specific heat capacity. Are you remembering this?
Yes, sir.
Meaning of this is, if I take 1 kg of any substance, suppose I insert thermometer here, it is recording 30 degrees. Then when I supply heat, its temperature will increase when it becomes 1 degree, 31 degrees Celsius. So what is changed? 30 became 31. How much is changed? Is it 1 degree?
Yes, sir. 1, 2, 3.
31 becomes 31 is 1 degree change. So whatever heat you gave, that is called specific heat capacity, denoted by X. So for mkg substance, if temperature changes by same amount, then definitely heat should become ms, because 1 किलो के लिए अगर s, तो 2 किलो के लिए 2s, 3 किलो के लिए 3s, q equal to ms. Not follow?
Understood,
Followed,
sir.
sir.
In this case, I have changed temperature by 1 degree. But if I take mass m and change the temperature by delta theta, then total heat becomes mass into specific heat into delta T. So specific heat capacity is Q upon delta theta. Its unit will be joule per kg Kelvin. This is specific heat capacity S का यूनिट. इधर तक समझ में आया? Specific heat capacity unit will be joule per kg Kelvin. Hello?
Yes, sir.
Just copy it in there.
Sir.
Copy it in there. Yes, completed. So completed till there.
Sir.
Okay. We are interested in heat capacity. I explained you specific heat capacity. Now from this, what is heat capacity? We did specific heat capacity. Heat capacity is heat for total mass. Heat capacity for unit mass. So if Q is total heat, then heat capacity H, this was for total mass, will be Q upon mass. Hello?
Yes, sir.
Heat capacity is heat required for unit mass. So for unit mass, it will be heat upon mass M.
Yes.
वापस करो।
Yes.
नहीं नहीं वापस करो। Specific heat समझा ना? Now
Yes, sir.
heat capacity करें। So not difficult, but terms are coming in between which you might have forgotten or not studied. Then slightly it may appear to be difficult at first stage. Heat capacity. Heat required for total mass to raise temperature by 1 degree Celsius is called as heat capacity. So we require total mass for 1 degree Celsius. That means Q is mass into specific heat into delta theta. This is for delta theta. I want heat only for 1 degree. So divide by temperature ms. This is called heat capacity. Heat for total mass, but unit. Unit means for 1. This was for delta theta. I divided by delta. The ms is nothing but heat required for total mass when temperature is changed by delta theta. So for 1, I divided by delta. So heat capacity is nothing but heat for 1 degree. Hello?
Yes.
Yes.
S means heat for 1 degree, for 1 kg. But we want for m kg. So m into S is heat capacity, which is from formula Q upon delta theta also. So can I say unit will be joule per Kelvin? जूल पर केल्विन।
Yes, sir.
ओके, अगर ये क्लिक हो गया तो अपना 11th सम हीट कैपेसिटी डायमेंशन इज जूल अपॉन केल्विन यूनिट से डायमेंशन। जूल इज m1 l2
L2.
p minus 2 and Kelvin k minus 1 because it goes up. So m1 l2 p minus 2 k minus 1 option p. Everybody has followed again?
Yes, sir.
Okay, right? Don't take any tension because as I said, till dimension there can be some tension up to if few quantities are new.
Done, sir.
Next one. Which of the following pair does not have similar dimension? Okay. Which pair is not having similar dimension? Stress means force upon area. Pressure means force upon area. That means they will have similar dimension because definition is same. We want not similar.
Yes.
Correct. Tension is similar to force, but surface tension is force upon length. So this is not similar, no? Correct?
Yes, sir.
My answer. Let us check C. Angle has no dimension. Strain also has no dimension. That means they are similar. That means these are similar. Even this were similar. Let us check now D wala, whether it is similar or not. Planck's constant, angular momentum, I already explained they are similar. Correct, no? Hello?
Yes.
Planck's constant and L. At the start of lecture, I explained you they are similar because L is mvr, H is energy upon frequency, and it is also given by one formula which I told. L is nh upon 2 pi, but you don't remember so many things. H and L, Planck's constant, angular momentum, are similar, related by this formula nh upon 2. Now we followed by B is our answer.
Yes, sir.
Yes, sir.
Yes, sir.
Sometimes it can happen. You don't know many quantities, but answer wala quantity you know. So whether I don't know or know relation of H and L, but clear cut I know tension is force, surface tension force upon length. Definitely they are totally different. So this is my answer. Copy.
Done, sir.
13. Which dimension of the dimension of resistance and capacitance are same as that of what? Resistance and capacitance. Resistance is V upon I. Capacitance is Q upon V. VB cancel. Q. I is, this Q is nothing but I into time. So we are left out with time. Therefore, RC is equivalent to time. Option B. 14. Copy 13. Then we'll go to 14.
Yes, sir. Understood.
14th one. Dimension of magnetic moment and angular momentum. Magnetic moment, I have told you its unit is ampere meter square. Angular momentum formula I told MVR. So from this A1, meter square means L2, mass is kg, velocity is meter per second, distance is L1, mass is m raised to capital 1, capital M raised to 1. Now L1 is L2 will get cancelled with this. So m raised to minus 1, P raised L raised to 0, P raised to 1, A raised to 1, m raised to minus 1, L raised to 0, P raised to 1, A raised to 1, option A.
Done, sir.
In the formula, x equals to 3y z square, x as dimension of capacitance, x is capacitance, z has dimension of induction denoted by B, then what is y dimension? Y dimension will be x upon 3z square dimension, that is dimension of x upon z square, because 3 is a number, it will not have dimension. Dimension is actually power of units. So no unit, no dimension. So this is C and this is magnetic induction B. C means Q upon V. And if you are remembering, F equal to Q into velocity into beta. So B will be F upon charge Q into velocity V, its square. So Q 14 potential is work upon charge into, this is q square, velocity v square upon force F square. Q goes up, Q square upon work, Q square, velocity V
So
square.
can you please write it on the other page because I'm not able to see it properly.
You're not able to do what?
So this is like, I'm not able to understand it properly then.
So far, I just
So this one, that side thing here, Q upon V, Q upon Q.
F equal to QVB. This we have not seen earlier.
So the other one right now you just wrote now Q upon V, sorry, Q upon W upon Q and all that.
V work upon charge. This QV goes up, will become Q square V square, F square. Then I have just taken this Q again up, Q square upon W. This is Q square V square upon F square. Please copy to this. Just copy till that. Till this, I think it is self-explanatory.
Yes, sir.
After this, I'm utilizing the book page. We got Q square upon work, Q square velocity square upon F square. Is it visible properly, Trisha?
Yes, sir.
Okay. If you are done till that, please tell me so that
Yes, sir,
final
done.
time. Okay. Q means IT. So IT means A into T. So square means A square T square. And work is M1 L2 T minus 2. Then that Q square will again be A square T square because it is IT. And velocity is meter per second. Force is M1 L2 T minus 2 square. So power 2. It will be A raised to 4 T raised to 4 L1 T minus 1 in numerator, denominator M1 L2 T minus 2 M2 L4 T minus 4. Followed?
Yes, sir.
After this, M1 M2 is M3 goes up M raised to minus 3 M part over. Now L2 L4 means L6 goes up minus 6. 1 minus 6 will become minus 5. M raised to minus 3, L raised to minus 5. Now T. 4 and minus 1 is 3. Minus 2, minus 4 is minus 6. Goes up plus 6. So L raised to 9. T raised to 9. Minus 2, minus 4 is minus 6. Goes up plus 6. 6 and 4, 10. 10 and minus 1, 9. And A raised to 4. M minus 3, L minus 5, P 9, A 4. We are not getting some mistake, it is done in between. Let's see again. Z is induction, that is V, which is F upon QV. QV went up upon F. So we got A square, T square, A square, T square. Oh, this was V square. I wrote only V. Got it the mistake? This also
Yes,
square.
sir.
Yes, sir.
This is square. So it will become A4 T4 L2 T minus 2. Now we get 1 L2, 1 L2 I can cancel. L raised to 4 goes up minus 4. Then minus 2, minus 4, minus 6 goes up plus 6. 4 and 6, 10. 10 minus 2, 8. This we have anywhere? M minus 3, L minus A8, L. What we got? L minus 4. Here it is given minus 2. Oh, L2, L4 is L6. Okay, again I'm clearing full and then explaining. Wait. X is 3y z square. Y is x upon 3z square. So dimension of y is dimension of x upon z square. X is capacitance C, Z is field B. So capacitance formula is Q upon V into B is force upon Q into velocity square of this. So Q upon potential is work upon charge. This is into Q square V square upon F square. So Q square upon work into Q square velocity square F square. Q is IT, so I square T square. I square T square into V square W F square. So we get A raised to 4 T raised to 4. Velocity square means L1 T minus 1 square upon work is M1 L2 T minus 2. This is M1 L1 T minus 2 square. So we get A4 T4 L2 T minus 2 upon M1 L2 T minus 2 into M power 2 L power 2 T power minus 4 M raised to minus 3. Now L2 L2 cancel. This 2 goes up. L raised to minus 2. 4 and 2 6.
So even the T2 T minus 2 also we can cancel.
1 T minus 2 will also get cancelled. So we get T raised to 8. A raised to 4. Now I think this is there. Huh? This option is there anywhere. M minus 3 L minus 2 T8 A4. Is it there?
Yes, sir.
At T. Correct? Option D. D is the answer. See, whatever I have given you the planner, its solution I will send as per that. So that you can check your answers, what you are doing. And anything which you are not following, in lecture I will clear your doubt. Because 200 sums we have to complete in this week.
Done, sir.
Okay. A quantity capital X is given by m e raised to 4 upon 8 epsilon naught square c into h cube, where m is mass, e is charge of electron, c is velocity, permittivity of space. What is dimensional formula for x is same as what? Dimension of x is same as what? What is mass ka dimension? m1.
Yes.
Q is charge, charge is it. So a1 t1 raised to 4. It has got no dimension. The c is meter per second, h is joule second. So m1 L2 T minus 2 into T1 joule into second raised to 3. Now if I can find epsilon 0, I get my answer. Epsilon 0 खाली dimension चाहिए. Let this be first one, epsilon 0 I am explaining. Since F means force, between two charge is 1 upon 4 pi epsilon q1 q2 upon r square. You have to remember this. Huh? This is force between two charge. So epsilon naught dimension. Epsilon naught is called one quantity permittivity. This is 1 upon 4 pi q1 q2 upon fr square. That means epsilon naught dimension is charge q1 q2 का dimension. मतलब indirectly q square का dimension. So it is I a2 t2 because charge is it upon m1 l1 t minus 2. This is l2. So we get m minus 1 l3 t4 a2 dimension of permittivity. Please copy till this.
Sir, in the last part, wouldn't it be L raised to minus 3?
L1 L2. Yes, very good. L minus 3. L minus 3. Yes, you are absolutely right. It's got permittivity dimension.
Yes, sir.
Now m minus 1 L minus 3 T4 and A2 is dimension of that quantity which is called permittivity. Now see M1, this is A4 T4. This we got m minus 1 L minus 3 T4 A2. This is L1 T minus 1 into M3 L2 3 is 6 minus 6 T raised to. Copy again this much.
Done, sir.
Just one more line. Simplifying this. M1 A4 T4 upon M minus 2 L minus 6 T8 A4 L1 T minus 1 into M3 M3 L6 T minus M minus 2 M3 is M1. So this will get cancelled. A4 gets cancelled. L raised to 6 L raised to minus 6 cancelled. Minus 3 minus 1 is minus 4. So T raised to 4 T raised to 4 L1 T raised to 4 cancelled. So we get L raised to minus 1 final answer. L raised to minus 1 is 1 upon meter. This is wave number. Wave number I have taught you. It is 1 upon wavelength.
Yes, sir.
So answer is wave number. कितना रामायण किया और देखो क्या आया. तो आप एक याद रख सकते हैं, बाद में तो मैं लिखा था. Just copy this one. Finally we got wave number because L raised to minus 1 is 1 upon length. 1 upon length is actually reciprocal of wavelength. This is called wave number span. Wave number's dimension is L raised to minus 1. Once you complete, then give signal.
Yes, sir.
Yes, sir. Done.
See, in 12th standard, you are going to study that M e raised to 4 upon 8 epsilon 0 square h cube into c is called as Rydberg's constant. In 12th, you have this everything. It is found to be its value r equals to 1.097 10 raised to 7 per meter. So if from after 12th I should have done this chapter, directly I would have told this is my Rydberg's constant whose unit is meter raised to minus 1. That means wave number, correct?
Yes, sir.
So that
Yes,
is
sir.
exam. After 12th you are going to write exam. You will not write so many steps. You will just remember it was Rydberg's constant, which is nothing but meter raised to minus 1. But in case you forget, then you should know how to derive also. I would have told directly कि इसको बोलते हैं Rydberg's constant, unit is meter -1, लिख दो L raised to wave number. But in case you forget so, then I should know how to substitute. So this write note. Note right.
Done, sir.
Okay. One last 20th. Some number 20 last one for today. 20th. Oh, we did 16th, huh?
Yes, sir.
Okay, I got 20. So today we'll stop here. What homework I have given to you all in that planner for today and